Chapter 21 is about our new renewable energy alternatives. The essential case is about Iceland moving towards a hydrogen economy. Now, hydrogen gas can be used to power our transportation, such as you can see here buses and also cars, and it would not emit any greenhouse gases nor any air pollution. And we already have prototypes, so we already have cars and buses that can run on hydrogen power. The challenge with hydrogen power is that currently it takes a lot of fossil fuels to split water into hydrogen gas and oxygen gas. And so if we can split it with renewables, perhaps it might be a good transportation alternative. All right, let's go ahead and turn the page to 622. We have some graphs here showing you that of the new renewable resources, wind leads, and then solar, and then you have a few of the others. And in the U.S., of our renewable sources, we have mostly biomass, then hydropower, and a few of the other items. And then electricity, a lot of hydropower, and then of the other items as well. On page 623, make sure you know passive solar and active solar. And we have some instruction on the next page about those. All right, so passive solar these are not photovoltaic cells yet. So passive solar is when you build a house, you build it so that your windows are facing south. And this captures sunlight in the winter because in the northern hemisphere, where we live, it's hotter at the equator, which is to the south. So if you build windows facing south, you're facing the equator, and more sun can come in during the winter. And so it warms your house up naturally from the heat of the sun. Now in California, we don't really consider that, that our houses are too cold in the winter. But if you're living in other parts of the country, there are a lot colder winters, and having a southern facing home is a good benefit. And then in the summer, you have overhangs to block that heat and shade that window to keep your house cooler as well. Another passive solar technique is to have some heat-absorbing construction materials, which also can insulate against the heat in the summer. So a brick home or a straw bale house where the insides of the walls are actually straw bales can insulate your home and protect it from heat and cold. And then we have active solar techniques. So this is using the heat of the sun plus a little bit of energy to disperse the heat of the sun. So a solar collector on the roof, like a solar water heater, some people have that at their homes. You can heat water, you can heat air, you can heat antifreeze with the power of the sun, and then you pump that heat, the water, the air, the antifreeze, through the building in pipes, and it heats the whole building. You can also concentrate the sun's rays through solar cookers, which are portable ovens, through a power plant with turbines, so the sun's heat boils water and spins turbines. And you can actually see this right here. This is a power plant where you have these mirrors that focus heat to boil water, and steam spins the turbine. So yes, solar power can actually spin turbines to create electricity. Another method of generating electricity that is not a turbine, and it's our only energy source that does not use a turbine, by the way, electricity source, is solar panels. The AP test will not use the word solar panel. They will use the word photovoltaic cell or PV cell. And this is where light strikes a silicon plate and electrons get freed within the silicon plate, and those electrons then flow through wires into somebody's houses. This process is also in calculators, and so we don't need batteries in our calculators nowadays. So on page 626, solar development in the U.S. has been slow because the funding has been erratic. We tend to subsidize oil and coal more than we do solar and wind. And fossil fuels are cheap because of subsidies. All right, so if you have PV cells, you can choose two ways to go about it. The first way is to be on the grid, which means you're still connected to the electric company. And if it's raining or at night, you can still buy power from the electric company. If you make a lot of power in your solar, your PV cells, you can sell that power back to the electric company, and we call this two-way metering. Houses off the grid. So if you live out in up in the let's say San Francisco Road, or up in Acton or Agua Dulce, and you build a house on a piece of land and you don't want to pay to be connected to the electric grid, then you can install solar panels, which again are called PV cells, and you can get a battery pack. And this battery pack can be charged during the day when there's sun, and then you use that battery pack at night for your lights and for other things you need electricity for. And so that would be considered off the grid. So we have here a map, and some places in the United States are better for solar than others. But even if you live in a place where you don't have quite as much solar radiation, there's still enough to power your house with PV cells. Turn your page to wind energy. On page 628, we show wind turbines and how they work. So again, all electricity except PV cells is spinning turbines in some way. And the windmill is just basically a big turbine that the wind blows. Wind's the fastest growing energy source in the world, and windmills over water are growing because steady winds and less turbulence. So there's usually wind blowing over the ocean, whereas on land, some places the wind kind of dies down at times. So over the ocean, they cost more money to maintain, but you get a more steady wind supply over the ocean. They build wind farms, and you can see them on the way to Palm Springs or Tehachapi. They build wind farms where there is consistent wind. Let's talk about the concept of NIMBY. This is on page 630. It stands for Not in My Backyard. People like the idea of wind, but a lot of people don't want to see it, and so they say, well, let's build a wind farm, but not in my backyard, not where I can see it. The same with landfills. It's NIMBY. I want my trash to disappear, but I don't want to see a landfill. And that's not everybody. To some people, they like to see windmills. It's visual proof of good renewable energy. 631, make sure you know the captions in the picture here, talking about wind power and what states provide wind. Now, you don't have to memorize the states that provide wind power, and California is leading the nation, so that's rather nice. Texas, there's a lot of windmills in Texas as well. But you can see here, you really have to map where there is wind before you build a wind farm. And on page 632, they talk about that. How do they map the wind? They prospect for wind. They find out what places get consistent wind, and that's where you would want to put your windmills. Page 633 starts talking about geothermal energy. And so these are places where naturally the groundwater, the aquifers, are close to the magma under the earth. And we can find these places and build a power plant where natural steam, so the magma is already creating steam, and then we can build a power plant and use that steam to spin turbines to create electricity. It's almost clean. There is a little bit of natural sulfur that becomes airborne, but not much. not like burning coal. And it is renewable as long as we don't overpump an aquifer. It is a renewable source of energy. Geothermal can only be built in places that are geothermically active, where natural hot springs occur, where steam comes out of the ground. If you've ever been to Yellowstone National Park, the geysers there and the other steam areas, those are natural geothermically active areas. So you can see it here on page 634. We have the magma comes really close to the aquifer, and so we can use that steam. So the water's naturally boiling underwater, and we can use that steam to spin turbine. And Iceland is the leader in this because Iceland is seismically active, volcanoes, lots of hot springs, and so Iceland has a small population and a ton of geothermal areas, and so almost all of their electricity is from geothermal power. And so they lead the world. Some experimental energy sources are waves and tides. So on this page, page 636, we have a picture here of how we would use tides and turbines. So again, these are a turbine and the water coming in for high tide and the water going out for low tide. The water movement itself would spin turbines, which would create, would release electrons in a generator, which is what electricity is. We can do the same thing for waves. Here, page 637, we have the picture and the caption which explains wave energy. The drawbacks to wave and tidal energy is that it may disrupt the marine habitats. We may disrupt migrating species like turtles that need to come into shore. The benthic community might become disrupted, and so that's one of the drawbacks to marine electricity, but not something that can't be overcome. So there's a lot of people looking for solutions. OTEC is theoretical. We don't use this yet, but basically the ocean currents and thermal energy contained in the oceans could possibly be used for electricity. And so this is a concept that is not being used, but it is possible in the future to be used. And last but not least, we have hydrogen. So hydrogen is a source that we could use for our transportation in our cars. So we have a hydrogen fuel cell, and the hydrogen fuel cell is where we split water into hydrogen gas and oxygen gas through a process called electrolysis. The problem, like I said earlier, is that we currently use fossil fuels to do this. This article here on page 638 that says algae as a hydrogen fuel source is experimental. We perhaps could use algae to create the hydrogen gas, and that would be sustainable. So again, right now we cannot make enough hydrogen sustainably without burning fossil fuels, so what's the point? We might as well burn fossil fuels in our car instead of burning fossil fuels to create hydrogen to burn in our car. So people are working on how do we do this, perhaps with solar or wind, to split the water to create hydrogen gas and oxygen gas. Now, hydrogen fuel cells have no emissions, no air pollution, no carbon emissions, so it would be a fabulous solution to our transportation and burning petroleum oil. The next page, page 640, shows how a hydrogen fuel cell works. You don't really need to know how it works, but it's kind of fun to see. And this is a bus on page 642 showing you that they do have prototypes and they are running them. And it is, again, a possible source of renewable transportation energy. That's the end.